In this video, we will examine inequalities. Now, you might have learned inequalities before, but let's take a look at them right from the beginning. So here is an inequality. And what does this mean? Right. So example of an inequality, x is less than 2. Well, what this means is x represents all, and this is an important thing, not one specific value, but it represents all values that are less than 2. Okay, so if you wanted to draw a picture of this, a graph of this, then you would take your number line and you would mark 2, and since this is your number line, it's anywhere you want it to be, so there it is. And less than 2 is less is to the left, so x is represented by all of these numbers that I'm shading here. So x can be all these numbers, all those numbers. Now that graph is not complete because I want to draw another one here just to sort of compare and contrast these two ideas. So the next one I want to talk about is this one. That little line, what does that mean? This means x represents all values that are less than or equal to 2. So again, x is everything that is less than or equal to 2. So if I were to draw a picture, again, it would look very similar to the first one. However, we know that the answer is slightly different. The difference is that on the left, 2 is not a part of the answer because x has to be everything that is less than 2. Versus on the right, 2 is part of the answer. So how can we distinguish these two results in their graph, right? And it's very easy. If you represent 2 with an open circle, open, then that means 2 not included. 2 is not included. On the other hand, if you put a closed circle right there, shaded in completely, closed, then that means 2 is included. So now this is the proper graphs for each of those pictures. Let's take a look at another one. And so second example, let's say we have x is greater than 3 and x is greater than or equal to 3, just to again compare. This means all numbers greater than 3, and this means all numbers greater than or equal to 3. And again, if you were to draw a graph of this, so we would take mark 3, and since this is strictly greater, we would put an open circle, and greater is to the right, so numbers like 4. You can always use a test number for x to see which side you should go. So for example, if I were to use the test number 4 for x, then you see that 4 is greater than 3, and hence you should go in that direction. If I had by chance used the test number 1 for x, you would see that 1 is not greater than 3, so that's 1 is on the wrong side. So you could always, if you're confused about what to do, put a number in for x and check to see how that works out. So here we go with this one. So here is 3 again, and again it's shaded to the right because we are greater than 3, and this 3 itself, make sure you shade it in right there So closed versus open, right? And let's take a look at another example. Let's take a look at another example, and this one here is looks like this: -2. So let me actually give slightly instructions. Graph -2 less than or equal to x less than 3, right? So this time x is any, I should say all numbers greater than or equal to 2 but less than 3. So excuse me. So here we go. Here is -2. I should say -2 there. -2, and here is 3. So everything that is greater than or equal to -2 but less than 3. So between those two, in other words, greater than -2 but less than 3. And -2 itself is included. It could be -2, but 3 is excluded. So open circle at the 3 and a closed circle at -2. Open and closed. Um, that's the graph. Okay. There is another notation, a couple of other notations that I want to introduce, and that is the interval notation. So let's take a look at this last example we did: -2 less than or equal to x less than 3. And so we drew the graph of this, as you see, with -2 circle completed in, filled in, 3 not filled in, and everything filled in. So this is the graph. Now for interval notation, that's a way of simply saying where the answer region starts and where it ends. It's called interval notation. So where does it start? This has to be the left. And where does it end? The number where it ends, or the right. Okay, the order is important. It's got to be left, right. So in our example, this would be -2, comma 3. Now, how do we tell which one was included and which one was excluded? And that's important. We tell that by using brackets and parentheses. So bracket indicates included and a parentheses indicates excluded. So this indicates -2 included. This indicates 3 excluded. Okay, so that's interval notation. Let's do another example of interval notation. So let's say example graph and give interval notation. Well, this time let's say we have x greater than 4, right? Actually, you know what? Let's do a slightly different example. Let's do 4 written this way. Now the reason I write it this way is people get a little thrown the moment I change the direction of the number and the letter. Now if this bothers you, meaning if the way that's written, it's written as 4 less than x, if that is difficult to understand, then change it. But when you change it around, make sure that the open end of the inequality the open end and the pointy end of the inequality are pointing to the same two things. So don't change it around like this. So don't do x like that, because notice that the pointy end now is pointing at the x and the open end is at the 4, which is not what you want to do. It is okay, however, to do this, because now you're consistent. The open end is still at the x and the pointy end is still at the 4. So this is simply saying x is all numbers greater than 4. So here is 4, open circle at 4, and shaded in right there. And if I were doing interval notation, it would start at 4, that's the left end. And what is on the right end? Well, since it goes on forever, we can only give a symbolic number. There is no number here at the right end. The symbolic number that we use is infinity, right? And the symbol for infinity is a sideways 8. If that's hard for you to write, you can put 2 zeros next to each other. Okay, so this would be a sideways 8 like that. Now the 4, because it's an open circle, will be a parentheses. Infinity, because it never ever can be reached, is always a parentheses, right? Now just as much as there is a positive infinity at the left, at the right end, there is a negative infinity at the left end. So if you ever had to use the left end, you would use negative infinity for your answers. Now we'll take a look at more examples of simple inequalities coming up in the next video.